Is it on? Yes. John Radalevich, Loughborough University. So thank you for those presentations, especially the ones that have compared the metrics and so forth. Could I just clear up a little bit of confusion about UDI, in that it has changed quite a bit since that first paper of 100 to 2000 back in 2005. So I think from about 2009 onwards, we realised the upper value was too low. And that was because there was a bias in the data, because we were looking at everything that was available, and it wasn't a lot, to be fair. But the early studies were showing low values around 2000, because I think they were carried out in offices with CRT screens, which were low in luminance and curved, and so they were not tolerant of high ambient illuminance levels. So I would certainly bump it up to 3000, which is what we've done for a while now. And also the range of 100 to, say, 3000, we divided at the design level, which typically now is around 300 lux. So I think it becomes a more sensitive diagnostic if you look at those four ranges then, and certainly between the 300 and 3000 you can start to make more of an apples and apples comparison with continuous daylight autonomy at 300 lux and so forth. But you know, great stuff to see, and also to see how sensitive it is as a diagnostic.
Yeah, of course, if you are changing the boundaries, you also change the sensitivity. You know, if you are higher, then it's become less sensitive than it is in this study. I don't know if you can hear me.
Oh, actually, I could. Yes, I'm glad Stoffer's got his hand up there, because the 100 to 2000 stuck for a long time because those are the limits in DaySim, and I asked them years ago to change this. So now we can put him on the spot. There he is.
It's all your fault.
Thanks.
Yeah. Why don't you go ahead and ask the question, then we'll borrow the mic back.
Yeah, I have a question to Elpida. I'll question your limit for when you're activating your solar shading devices, the Venetian blinds and the screen. It is very low. The official definition of direct sun is 120 watts per square meter. For instance, if you count the number of sunshine hours, that's the limit you have. So 50 watts per square meter is very low. So I would recommend that you use a higher value when you compare like this. I never really liked the idea of useful daylight illuminance, because there's no such thing as not useful daylight. There's only poor control of the daylight. So I don't like that, but anyway, if you compare like this, you should use the right limit. Thank you.
Well, when I refer to...
You got ahead. You guys share this.
Obviously, when I refer to useful daylight illuminance, not specifying the range of lux levels, I just meant the range that was desirable or creating comfortable conditions. It doesn't mean that daylight is not useful. It's just specifying the range that is most comfortable to the occupants.
Okay, Christoph, you get to defend yourself.
No, I don't want to defend myself. I think it's wonderful that we have this discussion here, and it's great that we are both in the same room, because there are obviously different opinions, even though we share a friendship on this. Well, the comment about not keeping up the DaySim code, it's open source code, so you can always fix anything in it. If you send it to me, we're going to put it online. I wrote that 15 years ago during my doctorate, so give me a break, right? No, I think the big thing is, of course, this discussion between daylight autonomy and UDI. And I think by putting them together, you're mixing two different things, right? So Jan and I wrote a couple of years this paper where we said, well, when we want to look at daylighting, we look at daylight availability, and then we look at visual comfort and energy and all these interesting things in between that combine these. And UDI is kind of a mixed metric, because it looks at daylight availability, and then it looks at this oversupply of daylighting. And I'm with Kjell there. If we calculated probably some moments during our conference here, the UDI distribution here, you might have had over 2 or even 3,000 lux in here. And then you have basically the C in the middle of where a lot of people are sitting. We say, well, this is not daylight. So I think that's a bit confusing for a designer. I think it's useful to say, okay, there's daylight availability, and of course, when you look at it, it doesn't vary that much with climate, actually, less than you think, because the daylight comes into the space, and if you look at your results, this is how much daylight you have. And then you have to basically have a discussion on energy. Is that daylighting bad? It might be bad from an energy perspective, because if you are sweating because of 35 degrees in there, it might not be that great, right? And then it's, of course, a comfort issue. But I think putting them together, it doesn't make too much sense. I mean, otherwise you should combine your daylight autonomy with some visual comfort indicator. But that's my opinion.
Yeah, but I think the one where they say, of course, everything, all daylight illuminance is beneficial, but where it also is that if we, an example, have different shading controls, and they are often set after illuminance level, and in this case we have just like, I think that the lower boundaries for actually both daylight autonomy and daylight illuminance was 200, so they had the same lower boundaries for this study. But we just chose 200 at the upper level, and when it is like in sample that we have continuous shading controls, then sometimes it's actually switched that, okay, if you have set it a certain boundary, though there actually is still a high illuminance, but the shadings might turning down, and you actually start to also turn on the electric light at the same time. So in this study, we're also having a bit more look at it for an energy perspective of view, like where is the brains and how they are reacting compared to each other in this kind of view.
Anybody else? Okay, question.
Okay, I have two comments. The first one is about that dynamic response you had, that you had just control due to the cutoff angle of the blind. And I agree with Christophe that adding some kind of glare prediction would be good. My own experience from measuring on a system some years ago in the lab was that the cutoff angle in the summer, the sun is so low that the blind can be horizontal and even tilted backwards, and you still have a cutoff of sunlight. And then you get quite a lot of diffuse light coming in, which can be glary. So usually you would need to close the blind quite a bit more than just the cutoff angle to prevent glare. Especially in northern climates, you can see that the cutoff angle of a blind can be negative. The second thing is a general question for all of you who's starting to use dynamic metrics. Is there any discussion on what climate is put into the metric? What year is it built on, and how different is it if you take different climate years? Because I know this is a big debate in energy simulation, and it's quite a big difference from year to year, especially in Scandinavian countries when it comes to summer overheating, and that the climate is getting warmer. It affects the energy consumption if you take one year or another, and how many years it's been studied before you pick out a normal reference year.
Anybody want to tackle that? That was a rather complex question. You know, it might be that, you know, the next group of speakers are going to be talking about daylighting standards. And maybe that'll get answered in the next session. That was a pretty complex question. Maybe we should wait for that. Mark, do you want to ask a question while you're here?
Yes, thank you very much for the quite sophisticated calculations, and I must say that I see something a bit awkward is the sophistication of the analysis and the shoebox simple architecture on the other side, which suggests, I hope that today we can solve shoebox problems without going to all this calculation. I hope that now we are there. However, I see a major difficulty between the sophistication of the tool presented by Henrik, which takes a given light as input, right? And something which was presented by the other groups where you run a whole year of data. And of course, we could couple the two, and then we get a fantastic story of the whole building during the whole year. But are we forgetting the key issue, which is the decision? The key issue is we want to make a quick decision, as quick as possible, as good as possible, of the design. So how do you see, all of you, when you want to take a decision, you make a decision, you want to know about the incertitude, the tolerance, right? Say, oh, I want to size this around this area would be good, right? So could you see, if we want to avoid to go into all this sophisticated climate-based analysis, together with the incredible sophistication of the 3D analysis, because we could go there, but I don't think that going there will make our building much better. We have to develop knowledge. So I'd like to have your views on that.
Who wants to start? Go ahead, Henrik.
I mean, one thing you could do is have a standard lighting environment if you want to assess the lighting inside. Because, I mean, daylight factor is a very simple description. It doesn't say much about how lighting falls. So if you had a standardized lighting environment, I mean, there are the CIE skies, but you can take those and make something a little more sophisticated, maybe. But other than that, I mean, you can do pretty much anything now. The algorithms are there to compute lighting inside spaces in very sophisticated ways. Climate-based modeling, we looked at that. It's very cool. I mean, it's still a simplified assumption. It still divides the hemisphere into little squares and so on. You don't have to do that. So today, all options are available. So really, it's up to deciding on a standard. And looking at some of this, when we do the calculations, I often wonder, why not just say, well, we want the room to have 100 lux or whatever fall on the surfaces, instead of talk about relative to outside and inside and so on. I mean, you could do something much simpler. And many of these more sophisticated measures, they try to integrate over here. Again, you can do a lot of that with calculations. It's just almost agreeing on it. And I think in the room, there are a lot of experts here that propose different standards. Some kind of group meeting between them and agreeing on a standard, I think would be very useful.
I just want to make a small comment on that. I think I'm right. The sophisticated methods that we're talking about they're not much complex to use. They're just as simple to use as the traditional methods we have been using. So it's just adding more sophistication in the method, but not actually adding up more time or complex analysis necessarily.
You know, I think one of the things we're hearing is actually the subject of the next session, which is to talk about daylight standards. So what I'm going to do is turn this back over to Florence and let her bring in the next speakers, and thank you all very much.